Okay, so it's time to do, I think, our ninth video here. Here we get started. The name of the video, or the name of the topic that we got to take care of now is Introduction to Set Theory. All right, so I'm just going to name it simply, sorry about that. Let's get my pen back. Set Theory. Okay, so where is this in your book? This is this is 2.1, I'm sorry. It's 2.1 in your book. Okay, now we need to do, show you what a set is, and we got a bunch of like little symbols that I got to show you what they mean. So here's a set. Set could be anything. It could be a bunch of cars. It could be cars and refrigerators. It could be cars and numbers. But obviously the easiest thing for us to do here usually is just to talk about sets that have numbers in them. And we'll be able to illustrate set theory using those sets like that. All right, so I'm going to put up four sets actually. There's the set called A. Here's the set called B. So you put these little brackets here, and inside the set I put the elements of the set. So these are the 1, 2, 3, 4, and 5 are all elements of set B. Okay, here comes the C and its elements. Set C and its elements. It's got 1, 2, and 3 in it. Here comes D. It's got 5, 6, and 7 in it. Okay, now, first thing I want to tell you, to try to show you this, how to use this, these symbols, there's something called a subset of another set. So let me try to show you what that means exactly. So B is rightly called a subset of A. Bear with me for a second. All right, that's information piece B. Yeah, I'm sorry, A. And then here comes in the next piece of information, that it's also correct to say that C is a subset of A. So this symbol that I've just shown you over here means subset. Okay, now let me keep showing you because this is going to start getting clearer, I hope. Now what about, here's another symbol. B is not a proper subset of A. So this symbol over here, let me just put it over here. I don't mean to write all symbols, but this one I want to tell you what it means. It means proper subset. Give me a chance to explain. I'm not finished. Just give me a chance. Okay, because I got to show you D. Now D, the information piece D, is that the C, the subset C, is a proper set of A. Proper subset of A. Now I can explain the difference. Why is C right over here, C is right over here, why is C a proper subset of A? Because all members of C are contained in A, but it's not equal to A. That's the main thing. That's why it is called a proper, C is a proper subset of A. B, on the other hand, this one over here, B, 1, 2, 3, 4, 5, is totally equal to A. Exactly equal to A. They've got the exact same elements. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's not a proper subset. The only way to be a proper subset is that all of your members are in the parent member, but you have some members, there are some members in the parent member that are not in the child member, right? That's why C makes it to be called proper subset, yes, but B, since they're all equal to A, then it is not a proper subset. Now what's this symbol over here? This symbol over here just means subset, not proper subset. This symbol over here just means subset. Okay, well, C is a subset of A, right? Subset of it's even a proper subset of A, but it's even easier to be just a subset. C is a subset of A. And B, even though it's totally equal to A, it is still considered a subset of A. It is a subset. It's not a proper subset. It is not a proper subset. That's why there's a line through that. But it is a subset of A. That's the difference between subset and proper subset. Okay, now those are those four pieces of information. Here comes in the next piece of information, E. D. Are we able to call D a subset of A? Are we able to call a D a subset of A? That's the question. Look at D. I didn't finish the bracket, I'm sorry. 5, 6, and 7. All right, look at A. They have 5 in common, but 6 and 7's in D, not in A. There's no way that this is a subset. It's not a proper subset, and it's not a subset at all. So therefore, I put a line through it. D is not a subset of A. Okay, information number, the letter F. Statement number F. The number 1, just taking the 1, that's an element. 1, here this is, they've got a special symbol for element. It looks like an 8. Set 1, the element belongs in set A. 1, so does 2, so does 3, so does 4, so does 5. 6 doesn't. But so therefore what this means over here is that, let me put it in English right next door to it. 1 is an element of A. Element of A. Okay, let's continue. What about information piece G? Statement G. 8, the element 8, wherever that may exist, the element A is certainly not an element of A, right? It's not there in A at all. So you use that symbol that looks like an E, but you put a line through it. 8 is not an element of A. Okay, now H. Here comes the next piece of information about this, how to deal with the symbols and stuff. There's something called the null set. It's either called the null set or an empty set. Null set, or another way of speaking about it is it's the empty set. Either way, it is a subset of all sets. Strangely enough, is a subset of all sets. All right, it might be strange, but that's how set theory works. Okay, then comes I, the letter I, meaning that's information piece I, that if I want to take the number of elements in D, using that little letter N, how many elements are there in D? Answer, look at it, 1, 2, 3, equals 3. And there's a name for this. It's called the cardinal number of a set. The cardinal number of set D is equal to 3. That's what we're doing there. Okay, so that tells you a lot of information about sets. There's some more stuff, but I want to go on to some really important things about sets, and then we'll go back and we'll do even more details. All right, just bear with me a little bit. I need another piece of paper. So I close this down and I get another piece of paper, and here we go. Okay, what have you got? As follows. You got set A. Set A is equal to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. You got set B, which is equal to 5, 6, 7, 8. 5, 6, 7, 8. It's got those 4 elements in there. You've got something called the universal set, which is all the possible numbers of these exercises. It's a universal set. We'll be dealing with that a little bit, so we can explain more, but it just means it's the entire universe that our problems are working with. And I'm making that universe for these set of problems to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's it. The universe is over. That's it. Okay, if I had an 11 here in A, then this wouldn't work with this universe. So I wouldn't be able to put an 11 or some other thing. This is our entire universe that we're working with in these problems. Okay, now here's problem number 1. What is A union B? Okay, I'm planning on answering soon. Just bear with me for a second. What is A intersect B? Also known as A and B. This is known as a union or right here. And this is known as either intersect or use the letter and. I mean the word and. Okay, that's the second question. The third question is, what is A prime, also known as the complement? So I'm giving you the vocabulary right along as we go. A prime. All right. Answer to problem number 1, A union B. A union B means we don't discriminate. We'll take everybody who's in A and everybody who's in B. Everybody belongs to the set A union B. So what do I write? I write 1, 2, 3, 4, 5, 6. Those everything that's in A. Then I also write the 7, which is here in B, and the 8. The problem is over. And here's the little trick that you might, if I didn't tell you, you might have got stumbled over, but maybe not. Do not write 5 or 6 twice. They only exist once. So you write all the elements in A and all the elements in B. They all belong to A union B, but don't write 5 and 6, which is here and here. Do not write it twice. Write it only once. It's got to be there, but only once. A intersect B. So that's or. I mean, we'll take you if you're in A or in your B. Either way, or you're in B, we'll take you. What about this? A intersect or and B will only take you if you're in A and in B. If you're in A only, forget it. If you're in B only, forget it. What are the 2 elements that are in A and in B? 5 and 6. That's the answer to problem number 2. What does A prime mean? A prime means you need to, whenever you see a prime or a complement complement, then you need the universal set. A prime means everything that is in the universal set, but not A. But not A. It's sort of, in just plain English, I'm going to put in parentheses because it's a little informal, not exactly math. It means not A. And where do we base it on? The universal set. So 1, 2, 3, 4, 5, 6, that's in A. 1, 2, 3, 4, 5, 6, forget about it. That's in A. So that's not part of A prime. What's in the universal set that's not in A? Well, 7's in there, 8's in there, 9 is in there, and 10 in there is in there, and therefore that is A prime. Okay, now let's move this up. As usual, I want as much paper as possible. And I want to show you, if I can, a Venn diagram where all this stuff belongs. A Venn diagram. So the first we're seeing a Venn diagram. We'll have to deal with Venn diagrams at length a little bit later. But we're doing just a rudimentary look at a Venn diagram of the information I just put up there. The Venn diagram has a universal set, that's the box. It's got a circle called A, and it's got a circle called B, and they have a little bit of space, overlap. This football in the middle is the overlap. Okay, so where would I put all the elements? Where do they belong inside this thing, right? So remember the universal set? See that universal set up there? Right there. I'm just going to try to get it for us to see it pretty clearly. Okay, here's where all the elements go. A alone, this part over here without the football is A alone. Who belongs there? 1, 2, 3, and 4. What about B alone? B alone is 7 and 8. That's in B alone. What about 5 and 6? That's inside the football because it belongs to both A and to B. 5 and 6. Now where does 9 and 10 belong? 9 and 10 is not in A at all, not in B at all. Where does 9 and 10? They belong inside the box. They're part of the universal set, but they're not inside A and B at all. And that is the complete job of the universal set in a Venn diagram, inside a Venn diagram of what we're doing here. Well, more about that later. We're finished with this video. We ran out of time.